Hello, everyone. Welcome back to this live series by PamTen. So, this is the third session in this live series. And in the first two sessions, we covered all the basics of Python. And then we also did some problem solving with Python. So, since this is a live session, you guys can go ahead and put in your queries in the chat section, and I shall look at them and I shall immediately give you the solutions or answers to whatever you ask. So I have my phone beside me, and whatever you ask, I will be able to see it, and then you can go ahead and ask those questions. So in this particular session, we shall be covering object-oriented programming. So we shall first understand the theory of OOPS, and then we'll go ahead and work with classes and objects in Python. Now, so we'll start off by learning what are objects and classes, and then there are some concepts called as constructors and inheritance. So we'll learn this. Now, what exactly is object-oriented programming? Well, in object-oriented programming, you have something called as classes and objects. Now, whatever you see around you, they are objects. So the laptop through which I'm able to do this live session, that is an object. So the car that you see over here, this is an object. These books, these are objects. This bag, this is an object. So anything that you see in this physical world, or you can say any real world entity, is an object. Now, if we want to represent all of these real world entities in the programming paradigm, that is where we'll need object oriented programming. That is, if I were to represent this car programmatically, or if I were to represent these books programmatically, that is where I need the concept of classes and objects. Okay, so we understand what objects are. These are basically real world entities. Now let's go ahead and understand what are classes. So you can consider classes to be a blueprint for objects. So what you have is a car, and a car has something called as features and actions. So this car, for it, the features would be its color, maybe its the number of wheels it has, the mileage it has, the speed. So all of these would be features. So every car will have a different color. So the color of a car is a feature. Similarly, the number of tires in a car is a feature. And then the speed of a car is also a feature. And then you have actions. So a car also performs certain actions. Now you can drive a car. So what are you doing over here? This is an action. Similarly, you can honk a car. That again is an action. You can also flash lights through your car. So that again is an action. And now, when you combine these features and actions inside this car template, you basically get something called as class. So you take this class called as car, and you say that, hey, this car class has all of these features. This car will have a color, this car will have a cost, this car will have certain number of wheels. And so those were the features. And also similarly, a car will be able to perform certain actions. So this particular car which you see over here, you can drive it, and this car will also be able to honk, and this car will also be able to flash lights. So these are the actions that you can perform through this car. Now, when you take this blueprint and make certain instances of this blueprint, or what I mean is when you basically create models from this blueprint, that is called as an object. So you have different companies for a car. So Tesla is an instance of your car model. Similarly, your Maruti cars or your Suzuki cars would be your objects for this car template. Porsche would be another object. So this is how classes and objects work in object-oriented programming. So now that we understand what exactly is object-oriented programming, let's go ahead and create our first class. So if we have to create a class, we need to use this keyword called as class, and the name of your class starts with a capital letter. So here you see that CAR here, C starts with a capital letter, and you go ahead and create these functions. So these functions are basically defining your actions for this car. So with the help of this car, you can honk. With the help of this car, you can drive. Now also you see that in the previous session, we had created a method, but we did not use this self parameter. So this is something new. So for now, you can understand that if we are creating a method or a function inside a class, that method, it should definitely have one parameter, which is self. So if you are creating a method in this class, there should be the self parameter. And if you do not create the self parameter, then you'll get an error. So this honk method has the self parameter. Similarly, this drive method has this self parameter. Now this self parameter is required because when we create an object of this class, we are basically telling this class that, hey, this method is being called by this particular object. So here when I say c1.honk, this would mean that I am creating an object of this car class. So here I have created or defined this car class, and for this car class I create a new object called as C1. And with the help of this C1, I am able to invoke this method which is part of the class. So when I type C1.honk, I am basically invoking this method. And if we do not give the self parameter inside this honk method or inside this drive method, I wouldn't be able to call this like this. So now that we've looked at this in the PPT, let's actually go to Google Colab and implement this. So here, let me just go ahead and create the car class. I shall give in the keyword class and I shall type car. So now that I have created this class, I can go ahead and create the method. So my first method would be honk. And since this is a method inside the class, I shall give in the self parameter. And what this does is it basically prints out, hey, since I'm a car, I can honk. So I'll just type I can honk. And then I shall have another method as well, def, and then I'll call this as drive. This takes in one parameter again, which is self. And again, this prints something. Well, this just prints I can drive. We have created our first class over here. Now let me just go ahead and see if there are any questions in the chat. Seems like we don't have any questions as of now. Okay, so we have successfully created this car. Now that we have created this car, let's go ahead and create an object. Okay, we'll call this car as Tesla. So Tesla is equal to car. And whenever we are instantiating, we need to give in these braces over here. So we can't just say Tesla equal to car, since we are creating an instance of this, so car, and then we given this braces, and we create an instance of this class car. So I have created this object. Now that I have created this object, since this object is a part of this particular class, you will see that I automatically have these two suggestions. I can invoke either the drive method or I can also invoke the honk method. So let me just go ahead and invoke the drive method and see what happens. You shall see that we have the prompt I can drive. Similarly, I shall also invoke Tesla dot I have honk. Let me also invoke this. Now, what I'll do is I'll remove this self method and see what happens. From here as well, I shall remove this. Let me run this over here. And now let's see what happens. You see that we get this error. Car.drive takes 0 positional arguments, but 1 was given. And we get this error because we did not give in the self parameter. So this class does not know what is Tesla over here. So it does not recognize Tesla as the object. And since I'm trying to invoke this method, which is a part of this class, I will get an error. So that is why I need this self parameter. I shall give it again inside, and now when I run this, you shall see that both of these methods shall successfully work. Okay, so we have created our first class and also created our first object. Now let's see what's in store. Okay, now we have created actions. We'll also add features to our car class. So here you see that with the help of these parameters. So till now we had only one parameter for our methods, and that was the self parameter. Now if I were to assign some features to my car class, so since a car has speed, a car has mileage, so what I want to do is I want to assign these features. And for this, I shall again use the self parameter over here. So what I'll do is I'll add a new parameter called as speed. Now you have to understand that this speed variable and the self.speed variable are different. So this over here on the left hand side, self.speed is part of your car class, and this speed over here, this is the local variable which I'm passing through this method, right? I'll repeat this again. The self dot speed is part of your R class. So whenever an object is created, for that object, there will be speed feature and a mileage feature because we are using this self parameter. But on the right hand side, what you see is speed and mileage. These are the local variables. So I can basically change this to speed to anything else. I can call this SP or SD. Similarly, I can call this mileage on the RHS as maybe MLG or just M. So we are passing this parameter speed into self.speed. Similarly, we are passing this mileage into self.mileage. Now we have set these values and I can go ahead and create two more methods through which we are returning these values. Now again, I'll go back and create this class. So we have our Jupyter notebook ready. Let me go ahead and clear all of this so that we have a blank coding space. I shall again create this class. So I'm typing everything from scratch so that you guys can also practice properly. Class, car, and I had to create my first method. So I shall call this first method as set. I need to give in the def keyword over here because def will stand for method, and without this I can't really create methods. Def of set speed. First parameter will always be self, and then I shall pass in the next parameter, which would be speed, and I shall just say self dot speed shall be equal to speed. And then going ahead, I shall create another method over here, def. Now that I've set the speed, I can also set the mileage. Set mileage, self mileage, and here I shall say self dot mileage is, this will be self dot mileage. So self dot mileage equals mileage. So I have created these two features. Now I can just go ahead and return these. I'll have two show methods as well. So by convention, normally whenever we are adding new features to our class, we use the set method. And if you want to get them, we use get method. So instead of show, I shall use the get method, get speed. And since this is also a part of the class, the only parameter will be self, and I shall return self dot speed. I have another method, and through this method I shall get the mileage, get mileage self, and I need to return the mileage, so this will be self dot mileage. I have created this class. Now I will go ahead and create an object. Okay, so this time maybe I'll need an Audi. So I'll create an Audi object from this car class. I have created this. Now I can just go ahead and invoke all of these methods. So let me first set the speed of Audi. So let's say its maximum speed is 200 miles per hour. Okay, we've set it. I'll also set Audi dot set mileage. And let's say the mileage is 30 miles per gallon. Now I can get the result. So Audi dot, I have get mileage. Okay, so I need to give in these braces over here. So here you see that the mileage which I've set, that is exactly what I get over here. So I've set in the value of 30, and as a result I also get 30. Similarly, I shall call Audi dot get speed, and over here I shall get 200 because that is the value I gave through the set speed method. So we've learned what are parameters. Now let's also understand another important concept, which is a constructor. So till now we have created methods like these. Now if I were to actually create all of the features exactly when I was creating the object itself, I can have something called as a constructor. So you can consider constructor as a special type of method in programming which will help us to instantiate all of our instantiate or give values to all of our features when we create the object itself. So here we can create a constructor in Python using the init method. So here def init, and there'll be two underscores before init and after init. So double underscore init, double underscore, and then it's the same thing. First parameter is self, and since this is a student will have a name, course, and age, and I'm assigning all of these values to the features of the student, and then I shall just go ahead and show all the details. Now let's go ahead to Google Colab and create this. Let me delete all of these cells from here so that we again have a blank page. So I'll have class student. Now for this student, I need to create a constructor. So def double underscore init double underscore. And again, since this is also a method, the first parameter shall always be self. Now after self, what does a student have? A student can have a name. The student shall also have age, and we shall also given the course that the student takes. Okay, and I shall assign these to the features of this class. So self dot name equals name, self dot age equals age, and similarly self dot course equals course. Okay, so we have created this constructor. Now I can just go ahead and show all these values. So I'll call this as def show, or maybe I can just call this as student details, and the only parameter is self. And what this does is it prints out everything. So name of the student is, here I can give in self dot name. Similarly, what else do I have? I have age of the student. So I'll type age of the student is, and I shall give in self dot age. And then finally, we have the course that the student has taken. Course of the student is. So here I shall have self dot course. Okay, we have created this class with these two methods, where the first method is basically the constructor. Now, if I were to create a student, I'll call the student as Kevin. So we have created our first student, Kevin, and till now what we were doing is, if we were to assign the values, we had to invoke the method. But now I can directly pass in the values while instantiating the Kevin object. So I shall give in the name as Kevin, and then let's say Kevin's age is 19, and the course that he has taken is maybe computer science. So computer science, okay. And then with this Kevin object, I can just go ahead and invoke the student details method. Can concatenate string, okay, Kevin dot student details. Let's see what the error is over here. So we have name, age, and course. That is what we are passing in over here. Student details. So dev student details. We are passing in name of the student as this, age of the student as this. Okay, probably I should also convert this into string. Okay, all right. So there, since what I gave in was 19, but 19 was an integer, but since we are concatenating an integer in a string, we got an error. So that is why I used the str method and converted the age to string. And now you see that we are able to successfully get the result. So here we have name of the student as Kevin, age of the student as 19, and course that the student has taken is computer science. So this is how we can use a constructor, and with the help of this constructor, we can directly pass in or instantiate this object with all of the required features. Going ahead, we'll understand what exactly is inheritance in a class. Now, what exactly do you understand when I say inheritance? Well, simply put, well, inheritance is something that you get from your parents or from your grandparents, isn't it? You inherit something from your family. Now, it is sort of a similar concept when it comes to object-oriented programming as well. So here you have something called as a superclass and a subclass. And the subclass, it inherits the features and the methods from your superclass. So again, you can call this as a parent class or a child class, and the child class will inherit your properties from the parent class. So here I have created this parent class called as a person, and this person has name and age, and I can just show out his name and age. Going ahead, what I'll do is I'll create a child class called as student, because a student is obviously a person. So this student takes in this person class. So student is a class which takes in another class as its parameter. So here what we can say is student class is inheriting from the person class, and this has its own method. Here previously person class had show details method, and student class, it has its own method which is show stu. And now here you see that S1 is equal to student, and I am passing in Emma and 12. How am I able to do this? Now student class does not have an constructor, but here person class has a constructor. So even though student class does not have a constructor, since it is inheriting from the person class, that is why I am able to pass in these values. And also here you see that S1 dot show details. Show details is not a part of your student class. Now, even though show details is not part of this, but since student is inheriting from person class and person class has show details method, that is why I'm able to invoke this show details method to this object. So let's go ahead and also create this very simple example of inheritance in Google Colab. Again, I shall go ahead and delete all of this. We shall need a clean coding space. I shall create the person class. So class of person, and this person, he will have a constructor so that I can give in his name and age, self, and this person will have a name, this person shall have age. So self dot name will be equal to name, and also self dot age will be equal to age. I have created the constructor, and I can just show the person's details. Def of, I can call this method as person details, and this will have only one parameter, which is the self parameter. And then I can show the details over here. Name of the person is, this will be self dot name. Similarly, I can use another print statement, and I can give in the age of the person. So I'll type age of the person is, here I shall give in self dot age. Okay, we have created this person class. Now I need to create a student class which inherits from this person class. Class of student, and this inherits from the person class, and this will have its own method. So I shall call this as student details. Again, only one parameter, which will be self, and this shall just print out I am a student. Okay, now I shall go ahead and create a student from this. Let's call the student as Emma. So Emma is our student, and we shall give in the name, and let's say Emma is 21. Now I shall create this. Okay, we have successfully created this object. Now I'll have Emma dot person details. Since the student class inherits this person class, obviously Emma is a person, and we can print out Emma's details. So we have this same error over here. I shall again convert this into a string. So str of self dot age. I shall run this again, and we see that name of the person is Emma and age of the person is 21. And also, since student class has its own method, I shall also invoke that. I shall call Emma dot student details, and hey, we get that I am a student. So, in this particular session, we've learned about object oriented programming. We understood what classes and objects were, and then we also understood what inheritance was. And we also implemented all of this in Python hands on. So, thank you very much for attending this session. If you like this video, do hit the like button, share it with your friends, and also subscribe to our channel. I'll meet you in the next one. Thank you.